Hello, my dear students. Welcome to the subject of statistics for the class 12th English medium part 1. Today we will be studying the chapter 3 linear regression. I will introduce this chapter to you guys and I am Vitan sir. The meaning of word regression here is to avert or return to the average. That means getting an average value. So this term was used by the statistician Sir Francis Galton, and he was studying the human inheritance. He collected the information of height of 1,000 pairs of fathers and sons, and he got some results. The first one was that tall fathers have tall sons and short fathers have short sons. But average height of sons of a group of tall fathers is less than the average height of the group of tall fathers. That means the sons of tall fathers on an average are less tall than their fathers. Opposite, for the short fathers, their sons are a bit taller than them. That means tall fathers have a bit shorter sons and the short fathers have a bit taller sons. So using this data, he said that heights of sons show some regressive tendency. That is, taller fathers have a bit shorter sons, that means going towards the average, and the shorter fathers have a bit taller sons, again going towards the average. That means that therefore we have people with all the kinds of height and not just tall and short heights. So he described this relationship of the fathers and son as regression. Now, what is regression? Regression is a functional relationship between two correlated variables. Regression is a functional relation between two correlated variables. Linear regression is the next step of linear correlation. For regression, it is the necessary condition that the two variables must be correlated. If the two variables are not correlated, we cannot calculate regression here. So regression is the functional relationship between two correlated variables. Actually, the regression model is a statistical model which describes the cause and effect relationship between two variables. That's regression model. I mean to say that the cause and effect relationship, when we calculated, that was correlation. But when the statistical model of cause and effect relationship between the variables is depicted, the statistical model of this relationship, then we call it the regression model. The cause and effect relationship was depicted by small r as a single value, but when we converted it into x and y equation, you must remember that there are always equations when two variables are included. So this equation, the model, the statistical model of this cause and effect relationship is known as the regression model. Usually, when two variables are connected with cause and effect relationship, in this case, in the regression, we will call a one variable which is a causal variable, that is an independent variable which does not depend on anything. We will call that independent variable x. Another variable which is a effect variable or a dependent variable which depends on the happening of x, we will call it y. Let us take an example. When we advertise in our business, our sales increase. So it's not that when sales increase we advertise more, it's the opposite. When we advertise more, our sales increase. So what happens first? The advertisement cost. So that is our independent variable x. What happens next? That is the sales. That is our dependent variable y. Taking another example, rainfall. Now rain does not depend. Rain does depend on the weather, but right now we have rainfall and the yield of rice. So between these two variables, rain doesn't fall because we take a yield of rice. We take a yield of rice because the rain falls. So what happens first is a rainfall. So that would be independent variable x. What happens next is a yield of rice. So we will take that as a dependent variable y. So right now we are calculating a independent variable x and the dependent variable y. And what we are thinking about, that if independent variable is there, how can we calculate the dependent variable y? That is, if we know that there is going to be a certain degree of a rainfall, can we estimate what will be our yield of rice? Answering this question is this chapter, regression. A linear regression model is a y is equal to alpha plus beta x plus mu. Alpha plus beta x plus mu. This is a regression model. That's a statistical model of the cause and effect relationship between the two variables. So that's a linear regression model, alpha plus beta x plus u. Here y is the dependent variable which we are going to calculate based on the x which is already given, the independent variable. So x independent variable is given and we have to find the value of y. Alpha and beta both are the constant values and u is the disturbance variable of the model. Now disturbance variable also means an error variable. If our model is not perfectly linear, then there might be some errors in estimation, and we have to take into consideration this error of estimation, and for that we have depicted it using the u, that is called the disturbance variable. Now if this u, that is the lack of linearity between x and y, which is depicted by u, is 0, that means there are no inadequacies, there is no disturbance, there are no errors in our equation. Our equation is perfect, our equation is perfectly linear. Then we can only write alpha plus beta x. We don't need u, because u is 0, because u is not there, because there are no errors. But when the correlation is not perfectly linear, but the correlation is a partial correlation, as we have studied in the previous chapters, that not all linear correlations are perfect. Some correlations are partial when they are not 1 or -1. When they are in between, they are called partial correlation. And for those partial correlations, there are errors. And because there are errors, we have to find u. So if we want to know the exact definition of a linear regression, a mathematical or functional relationship, a mathematical or a functional relationship between two correlated variables. This two correlated variables words is important, because without correlation we can't calculate regression. So a mathematical or a functional relationship between two correlated variables which helps in estimating the value of a dependent variable. Here the dependent variable is y. So what does the linear regression do? It helps us in estimating the value of dependent variable for some given value of the independent variable. Here independent variable is x, and the value of x is always given, it is always known. So a mathematical or functional relationship between two correlated variable which helps in estimating the value of dependent variable, that is y, for some given or known value of independent variable, that is x. That process, that function, that relationship is known as linear regression. I will read it once again, straightforward. A mathematical or functional relationship between two correlated variables which helps in estimating the value of dependent variable for some given or known value of independent variable is called linear regression. Now, regression is explained through a line. Regression is always explained. Linear regression means the straight line. So regression is explained through a line. So a scatter diagram when we create of two correlated variables, and if all the points are on a certain line, or not exactly on a certain line, but they are around a certain line, then we can say that it is a linear regression. All the points are on a certain line, then it's a linear regression. We have already studied this making of a line in the correlation chapter. The method of obtaining such a line or a relationship between two variables is called fitting of a regression line. That means when we can explain or when we make a relationship in a straight line between two variables, we say that we are fitting a regression line. Now there are two methods for fitting a regression line. Huh? The first one is method of scatter diagram, and the second one is a method of least squares. Now in this method of scatter diagram, if you recall, we have already created a scatter diagram in the correlation chapter. So we will be creating something similar, but in the regression chapter the scatter diagram is not used. It is only for the explanation purpose. It is not used for the sums. The method of scatter diagram, first we will be making the graph paper, and for just the sake of explanation I will be plotting certain points like this on the graph. Now after plotting down all the points, we have to draw a line. That line will be the regression line. That will be the fitting of a regression line. But is there any particular rule about how to fit a line? Let me draw one line here. Okay, this is a line which passes closely through all the points. But if it's not me and it's you, you might want to draw it like this. And if it is someone else, that person might want to draw it like this. The problem with the scatter diagram method of fitting a line is that anyone can draw any line they like. There is no particular rule of fitting a particular line. So the problem is that if 100 students are answering a paper or if 1,000 analysts are analyzing a certain trend, everyone will draw a separate line and we will have 1,000 of linear regression lines, and that way we can never get an answer. So in the method of scatter diagram, this is the main limitation of this method, that it is not consistent. This method is not consistent at all. Anyone can draw any lines, and therefore this method is not used in the practical methods. We will move forward with this second method, the method of least square. That means in this chapter you will only be studying this one method. Now here the word is the least squares. As you can see from the graph paper, the x1 y1, x2 y2, xi yi, xn yn, written in the brackets, the points which are not on the line, those are our observations. And then we have drawn an estimated line from them, and vertically we have drawn lines from our observations towards the arrowed line, towards the trend line, and those observations are named as x1 y cap 1. The triangle on y is the y cap, that is the estimated value, x2 y cap 2, xi y cap I, xn y cap n. So these cap values are the estimates of the original values which are on the points. So pointed values are the original values and values on the line are the estimated values. You can see here E1, E2, EI, EN. E stands for error. So the observations on the straight line are the estimated observations, and the observations on the dots are the actual observation, and the difference between the actual observation and the estimated observation is recorded as an error, that is E1, E2, EI, EN. That means the original and estimate has a difference. That way our answer might change. So that is an error. What we do in the method of least squares is we try to minimize these error. How can we minimize this error? By changing the position of our straight line. If we try to keep this straight line as near to as our original observations, the length of these E values will be shorter. If they are shorter, that means they have less error. If they have less error, that means our answer will be more accurate. What we have to do? We have to shorten the distance of this E1, E2, EI and EN values. That is called the least squares, because the errors are depicted as the squares. The total of all the squares, it should be the least. So that is called the least square method. But right now we will not be doing it graphically, but we will be using the equations for that method, and that is y cap is equal to a plus bx. So the estimated value of the y is known as y cap, and the equation which we are going to use here is the a plus bx. Now if you remember the original model, that was alpha plus beta x. So alpha has been replaced by a for the sake of simplicity, and beta has been replaced by b again for the sake of simplicity. Here a and b are the constant, and in this question, in this chapter, it is all about calculating the values of A and values of B. The vertical distance here, as I have just explained, the vertical distance between the original observations and the estimated observations is known as the error. It is depicted by EI. So error is the difference between original observation yi and the estimated value y cap I. So in equation, if we write it down, error is original observation minus estimated observation, that is EI is equal to yi minus y cap I. Here yi is the original observation and y cap I is the estimated observation. Our equation, because we are calculating the estimate of the observation, y cap is equal to a plus bx, and the formula for b here is summation x minus x bar y minus y bar divided by summation x minus x bar the whole square. Now my dear friends, if you have your notebooks in which you have written down the correlation formulas, all of the correlation formulas, then just open them and compare them. In correlation, this formula was something like summation x minus x bar y minus y bar upon under root summation x minus x bar square into upon root summation y minus y bar square. In the formula for regression, as you can see, this second formula also, you can see that y values are not there. The values of y are not there, because the y is the dependent variable, and we divide our regression model only with the independent variable. Now because earlier there were two variables, we multiplied them and then found the root. Right now only one variable is there, so we are not going to use the roots. So if you can remember all your correlation formulas perfectly, there is only a small variation in this regression formula. The b here is denoted as a regression coefficient. The b is known as the regression coefficient. The r was the correlation coefficient, and b here is the regression coefficient, and the formulas are like this. Once we calculate the b, we calculate a, and the formula for a is y bar minus bx bar. That means you have to calculate the b first, and then only you can calculate the a. B, the value of b is obtained, and this method, this b is called the regression coefficient for the regression line of y on x. Here the y is dependent variable, x is independent variable. So we are calculating regression line of y which is on the variable x. So we call it regression line of y on x. B is also known as the slope of the regression line, that is how steep or how positive negative it is, and the A is called the intercept of the regression line. Don't worry too much about it, you just have to worry about how to calculate it right now. Don't worry about its names, just remember it as a theory. Now interpretation of the regression coefficient B. Now b is the change in the value of y for a unit change in the value of x. That means if b is 5 for example, then if x changes by 1 units, y will change by 5 units. Now b, that means the b is the change made in y. B is the change made in y. That means with the change in x, how many times there will be a change in y. That is what b suggests. That means if b is more than 0, that just means that x implies an estimated increase of b units in the value of dependent variable y. If b is positive, the units of y will increase. If b is negative, then there will be a decrease in the units of the y. So b positive means y will increase and b negative means y will decrease. One thing we have to we have to be very sure about that the regression line obtained using the least squares method is known as the line of best fit. Sometimes in a question they don't specifically say of regression line, they say find the line of best fit. So that way we have to calculate the same thing. The note here is usually b is written, but it is byx, that is b for a regression line of y on x. But we always find a regression line of y on x. There is no regression line of x on y at your level. It is there, but not at your level. So you are only going to calculate y on x, that means byx. So we will ignore the yx suffix and we will just write b. Second point here is a important thing, that if the error is 0, if the error is 0 for all the values, that means there is a perfect correlation. That means the estimate of y cap is perfect. The estimate of y cap itself is the observation y. So in this situation, r is either 1 or r is either -1, because there is a perfect correlation. If r is 1, then b must be positive because there is a positive correlation, and if r is negative, then b should be less than 0. Just keep this much into mind, and with this I will end the today's tutorial. I am not going to teach more than this. This much, if you try to understand it well, that's enough for today. Your homework is read this theory from the textbook itself, and then once again watch this tutorial for a better understanding and write it down as a notes. Next time we will start with sums based on this list squares method, because I personally believe that sums, when we do sums, we understand everything. Just reading theory is quite boring for me. So see you soon. Till then, with certain sums. Stay home, stay safe, study hard.